My name is Richard Fisher, and I am with Autonomous Media. We are broadcasting live streaming from Orlando, Florida at Xponential. Autonomous Media is the publisher of Inside GNSS, Inside Unmanned Systems, and Inside Autonomous Vehicles. We are delighted you are all here with us today. Today we are talking with Tomas Pribanic of Undefined Technologies of Miami, Florida.
Right.
Miami, Florida. We've got a lot of Floridian companies checking in today. We're delighted with that. Welcome, Tomas.
Thank you, Richard.
Yeah, great. We appreciate you making the time for us. So, Undefined Technologies is kind of an interesting brand. But tell our listeners what Undefined does specifically.
So, Undefined Technologies is a startup company based in South Florida, and we are developing a silent drone using ion propulsion technology. Instead of using loud rotating propellers, we are energizing the ion cloud around the drone to accelerate the air extremely fast downward to generate upward propulsion. And we're going through the different stages of funding. We're at early stage pre-revenue startup, but our technology is definitely proving to be the future of propulsion. We have several investors, all of which are extremely proud and happy with our progress because we have proven over and over that the technology is heading in the right direction.
Tomas, tell us some of the advantages of ionization in terms of a propulsion technology and how it kind of compares with current systems that we're all kind of used to as we sit next to, the viewers can't see this, but we're sitting next to a bunch of aircraft engines, UAV engines, internal combustion engines. Tell us why that's old tech and why you're new tech, and what is the technical challenge related to bringing ionization to market at scale.
Mm-hmm. Very good. So I think the Wright brothers did an excellent job in generating lift using a pressure differential 100 years ago. And we've been doing that for the last 100 years. And
Indeed.
We've been doing a very good job. We've been optimizing that, but it's time for a new technology. Undefined Technologies envisions that ionization is the next frontier, which is a new method of generating propulsion, but not just beating the air with a blade, but instead energizing the air. And by that ionization, then it generates a lot of benefits, such as a propulsion system that is really quiet, it's very silent. See, there's no moving parts. It's also fully electric, so it has no carbon emissions, and it's very reliable. Since it has no moving parts, it has low wear and tear, and therefore it can extend the life of the drone.
Right. Tomas, can you, for our listeners, kind of explain to us in layperson's language just how this system, how ionization creates lift?
Yep, that definitely. So in basic principle, the air that we're breathing now contains ions at some degree. So when you ionize the air, what you're doing, you are beating those molecules of air with either electrons or some other part of particles. And now those electrons or those molecules go under what is called Inelastic Collisions, where they lose or gain an electron. Mm-hmm. Then those molecules are polarized, and they will get attracted to an opposite polarity. So when you expose those molecules to an opposite polarity, they will travel extremely fast towards that. In this case, it's called an electrode.
Okay.
And by doing that acceleration and following Newton's second law, that generates lift.
Wow. Okay. So is this technology a well-known and well understood by, we've done more than a couple of interviews with NASA and the Jet Propulsion Lab, and people who not only think about propulsion all day, but actually profess it,
Mm-hmm.
So
Yes.
they're always looking at the most efficient method of propulsion.
Right.
So how widely known is it? Give us a little context
Sure.
on ionization, if you
So
will.
yes, so the principle of the technology is not new. It was originally discovered by in the 1940s, and NASA has used the ion propulsion for space applications widely. So most of the deep space vehicles use ion propulsion using xenon gas as fluid.
Got it.
So they use xenon gas because xenon gas has a very high molecular weight, and the higher the molecular weight, then the higher the level of propulsion. But the problem with using that in air is that air is a very tricky fluid to ionize. It likes to dissociate in many ways. So this has been tried before, but the level of thrust or propulsion that has been generated previously did not allow for a weight to thrust ratio to make it a viable option for propulsion in atmospheric conditions. Now, the technology that we're developing...
In atmospheric conditions on this planet, anyway.
On this planet and other planets as well.
Okay.
As long as there is a fluid to ionize, this technology can be
And the
applied.
optimal condition is what?
The optimal condition is where there is, well, let me talk a little bit about the challenges. I guess
Okay.
that's gonna give you a little more context about what the optimal conditions are. So, when you're using ionization, and this even applies to spacecrafts, you want to be able to generate high voltage differentials between electrodes in order to propel those ions in between them. So there is a limit of how much voltage you can apply based on the dielectric strength of the fluid.
Okay.
Right? So the dielectric strength of air allows for voltage to be applied until a certain level, and beyond that you're going to get what is called arcing. And when that happens, then you lose all propulsion. So there's a lot of tricks to get around that issue, and a lot of discoveries that we've done in order to overcome those challenges.
Understood. And it sounds to me like, Tomas, you solved those problems. So they say the proof is in the pudding. So that sounds great conceptually, abstractly. Ionization is done in deep space, and JPL does it lots of places,
Yes.
out in well beyond the Kármán line, right? But you are doing it here in Earth's atmosphere. Tell us about your first flight. As I understand it, you've had not just one, but two separate proofs of concept.
That is correct.
Tell us about that.
So yes, we are going through different milestones as we improve our technology and make it even better. So we have two flights. One was April last year, and it lasted 30 seconds. Our craft measures 5 feet by 5 feet.
Okay.
And it was a successful flight. It showed the proof of concept, and from there we move into our second flight. Which
So you had a Kitty Hawk moment.
something like that. Yes,
You had a
yes,
Kitty Hawk
yes,
moment.
yeah,
Okay.
I can say that.
To use the earlier Wright brothers reference. I mean, this podcast is called Get Inside the Future. And of all the podcasts, I mean, this is really getting inside the future, isn't it? So tell us about the second test flight.
So after we learned a lot of lessons on the first flight, we set up to make some changes, make sure we push the technology even further. And on December last year, we had our second successful flight, which now lasted 2.5 minutes.
2.5 minutes.
Yes.
Duration. And at what altitude?
Well, we're doing about this altitude. So it was an indoor test.
Indoor, of course,
Yes.
sure. Yeah, I mean, you want optimal conditions. You don't want to deal with, wind and rain and the
Yeah,
environment. I mean, so that's a pretty significant step improvement in performance, isn't it?
Yes. And if you give us another month, we're going to double that. So
Okay.
we'll see.
So you have a third test
third.
flight scheduled.
Yes.
Tell
for
us
next
about
month.
that. What do you expect to see there, Tomas?
So we expect to see a much longer flight time. We have upgraded all of our electronics So now that they are to a point that I'm satisfied with it. So
Okay.
it's gonna be a much more refined craft. Our goal is to get to a minimum viable product by the end of this year, so that we can actually have a commercially available prototype. So that's what we're going through now.
So if you were going to describe the technical readiness level of your product now, where is it?
We're in a TR level 4.
You're a TRL 4.
4, yes.
Impressive.
So we want to get to a TR level 7
Right.
in the next year or so. So that's the goal.
So what do you think the commercial opportunity is for the ionization technology as delivered by Undefined Technologies?
So the use cases are pretty broad. So we can start by just doing urban cargo delivery in areas that require very low noise drones. So anything that has to do with urban areas. Then we have surveillance. So we can do
last mile delivery with
yeah,
drones. Yeah.
Last mile
Okay.
delivery.
Yep.
Yeah. Then we have surveillance, to where we can do a lot of reconnaissance applications that require very low noise as well. Then we can go into the military sections as well, that they're very interested in doing reconnaissance missions with our
Sure.
technology.
Sure.
And we also want to do delivery of intelligence and vital cargo for the military as well.
Yeah, clearly those are user communities that would really value the low kind of sound profile. There's a number of Army programs going on right now. Future Tactical Uas, which is the Group 2. 3 of the 4 are VTOL. Of the platforms that are in consideration, but some of the newer ones were really interesting because of the low sonic footprint. It makes a big difference, and particularly in ISR applications. It's always been a bit of a challenge, right? So, what about commercialization of Undefined Technologies? And by the way, to remind listeners here, you're joining Get Inside the Future podcast by Autonomous Media, publishers of Inside GNSS, Inside Unmanned Systems, and Inside Autonomous Vehicles. And we are with Tomas Pribanic of Undefined Technologies, having a fascinating discussion, literally getting inside the future as we speak. Tell us about the commercialization product roadmap. How do you see your solution building out as you take it to market for those various user communities that we just discussed?
Yes. So we have different projected revenue streams. So one of our market research and our potential customers have provided feedback that they need some type of propulsion that will get them up in the air from ground zero to their preset altitude. So right now they're using 2 types of propellers, one to take them up and the second one to take them forward. They want to replace the current propellers they have with our technology, so they want to buy thrusters from us. And then by retrofitting their current fleet with our thrusters, they can meet the FAA regulations regarding noise. So that's one of the avenues.
So that's
that
an
have.
aftermarket application.
Correct.
You do not have to be, and the advantage of that, of course, is that you've got kind of a built-in user base already, and you're simply selling an improved
Correct.
propulsion capability that's got lower noise, different kind of maintenance, more efficient. Tell me about what's your anticipated range and flight duration? At what point will you say we're ready now to actually take this to market, where it's not just the Wright brothers moment,
Right.
or you've got to, what do you think the functional performance needs to be, both in terms of flight time and duration. And are there any constraints related to altitude at all, or none?
Well, unless you go into the ionosphere, which is extremely high, you'll be fine.
Okay, well enough. Great. Glad I asked.
So yeah, but back to your question of what is the range that we need to achieve in order to become commercially viable.
Yeah.
So we met with all the big shipping companies.
Yep.
And the consensus is that we need to achieve 15 minutes of flight with 2 pounds of cargo to play ball.
Well, and by definition, that specification is what they will tell us is the average. I mean, that's last mile delivery land.
Mm-hmm.
That is absolutely, 80% of packages
costs, yeah.
Our package costs are in the last mile. The vast majority of them are less than 2 pounds.
Mm-hmm. Mm-hmm.
So that's really what's driving that. And you see that as the first kind of milestone capability that you need to deliver. That is your point of access, mm-hmm. essentially.
That is correct. That's what we need to achieve.
So once you do that, Thomas, tell me about what then? Mm-hmm. Is it, you talked about military, you talked about ISR. ISR by definition requires, the highest form of ISR frequently is, persistent surveillance. That's
right.
That's all the time.
Mm-hmm.
So, where's that next tranche of opportunity for Undefined Technologies?
Yes. So Undefined Technologies is a high-tech company, and our goal is not to become the biggest drone manufacturer in the world. We want to have this technology fully developed and license it to current drone manufacturers, so that they can take advantage of the benefits of the technology.
Drone manufacturers, aircraft of any type, platforms. Mm-hmm. Do you envision any propulsion that is not aviation-based?
There's a lot of research being done in ionization of water. We haven't started there, but yeah, there's a market.
But I was thinking more in terms of ground vehicles.
Mm-hmm. It could be used,
or multi kind of modality
mm-hmm.
Air ground vehicles.
It's possible, but it's similar to trying to use an air vehicle or a turbine to move a vehicle. I don't think that might be the best way to do it.
Got it.
Yeah.
Got it. No, I was just thinking kind of the flying car and advanced air mobility mm-hmm. types of markets that we're hearing a lot about.
Right.
So it sounds to me like you are well on your way. Do us a favor, check in again with us at Autonomous Media, Tomas. We wish you nothing but excellent success in your endeavors. And if you would please, just for our listeners, kind of summarize the value case, the set of benefits that you see Undefined Technologies delivering for your users.
Definitely. So Undefined Technologies will be delivering an extremely advanced propulsion system that delivers a level of noise below 70 decibels, that uses no moving parts, and sets the stage for the future of propulsion.
And it does so with minimal carbon footprint.
That's correct. Fully electric.
Okay. Well, you were getting inside the future with Tomas Pribanic of Undefined Technologies. I want to thank you for your time today, Thomas.
Thank you, Richard.
Congratulations on your fine, innovative work, and we look forward to hearing more from you in the very near future.
Excellent.
I'm Richard Fisher for Get Inside the Future. Thanks for joining. Bye-bye.